Hey everyone, it's Mikki here. You're listening to Mini Mikkipedia, and today I want to chat about something which I personally found pretty interesting actually, and I do think it has real implications for how we think about metabolic health, and that is the term metabolic memory. Now, when most people hear something like metabolic memory, they might be thinking of something sort of positive, much in the way we think about muscle memory. And there is a positive side to it, which of course I'm going to talk about. But the concept actually originated from diabetes research, and it paints a much more sobering sort of picture. It tells us that our bodies don't just respond to what's happening metabolically right here and now, but they remember what happened in the past, for better or for worse. And that memory can persist even after you've cleaned everything up. So today I want to chat about both sides of the coin, the bad and the good, because I think understanding this concept changes how you approach both metabolic health, whether you're a clinician, a coach, or somebody who's just managing your own health through the various tools with which you do that. So I want to start with the history behind the term sort of metabolic memory. So in the clinical sense, this describes a phenomenon where the harmful effects of a period of poor metabolic control, we're talking high blood sugar, hyperlipidemia or dyslipidemia, that kind of thing, when this persists and continues to drive disease progression, even after those metabolic parameters have been normalized. So you could bring someone's blood sugars right down into the normal range, but the damage keeps ticking along. And this was first identified through some really important clinical trials. So the big ones being the DCCT, the Diabetes Control and Complications Trial, which ran from 1983 to 1993, looking at type 1 diabetes, and its long-term follow-up study, the EDIC trial, which has been running from 1994 and is still ongoing. I ended up actually looking up the history of metabolic memory because I was so interested by the term and its implications. So what these studies showed was that the group who had intensive insulin therapy early on had significantly lower rates of retinopathy, nephropathy, and neuropathy. And these are three conditions or comorbidities, if you like, of type 1 diabetes. And this is the thing. Even after both groups' HbA1c levels converged, so they were achieving similar blood sugar control, the group that had good control early maintained that advantage for years. The early intensive group was protected. And that's something called the legacy effect. And it is interesting, actually, if I'm thinking about when I had a couple of interviews I did with Andrew Kutnick, who's a PhD, who he himself has type 1 diabetes, and I've talked to Adi Dykman on his son's experience with type 1 diabetes and managing blood sugar levels, and just how critical those early years are and how difficult it is to get right. Anyway, this is the legacy effect. Early intervention here has a marked influence on markers later on. And then we also saw something similar in a study called UKPDS for type 2 diabetes. So early intensive control provided about 10 years of protection against heart attacks and death. The STENO-2 study showed over 13 years of reduced cardiovascular disease risk from an early multifactorial intervention. So the take home from all of this, as I'm thinking you'll gather, timing matters enormously. Late-stage intensive control often fails to halt the progression of complications because by that point, the metabolic memory is already established. So how does this actually work at a cellular level? There are three main drivers. So firstly, we've got these epigenetic modifications. So we're talking about changes that don't alter your DNA sequence, but do change how your genes are expressed. So high blood sugar levels, for example, induce changes in something called DNA methyltransferases. And this is when the DNA methyltransferases is supposed to do something like add a methyl group to assist a cytosine base in your DNA, which typically silences that stretch of DNA. Like it's like putting a do not read sticker on that page of the blueprint. So the gene is completely there, is still there, completely intact, but the cell's machinery skips over it. And the thing that hypoglycemia does is it attaches methyl tags on genes that shouldn't be silenced, and those tags are stable enough to persist even after the blood sugar comes back to normal. Another example is a histone methyltransferase, and this adds a methyl group to a histone protein, which is the spool that DNA wraps around, and the effect can go either way. So it can either tighten or loosen the chromatin depending on exactly which amino acid on the histone gets tagged and how many methyl groups are added. And the methyltransferases, whether they're DNA or histone, they're one of these key writers of epigenetic information. So they're the enzymes that physically create the marks that constitute this metabolic memory. So when you get these changes that high blood sugar, for example, creates, it isn't the cell itself or the DNA itself that's being altered, but it has implications for all of these other pathways that lock in these changes that shouldn't necessarily be locked in. Second of all, we've got oxidative stress, and it's a vicious cycle. So excess glucose ramps up reactive oxygen species production in the mitochondria. Those ROS, reactive oxygen species, damage mitochondrial DNA, and this leads to even more ROS being generated. It becomes self-perpetuating. Even after glucose levels are stabilized, the mitochondria are already compromised. And the third cellular driver of metabolic memory is these advanced glycation end products, AGEs. These form when sugars react non-enzymatically with proteins and lipids. And the critical thing about AGEs is that they are resistant to degradation. They persist in tissues and they bind to a receptor called RAGE, which triggers sustained inflammatory signaling cascades. So even once your blood sugar is fine, these AGEs are still sitting in your tissues, causing problems. And there is systemic fallout. So metabolic memory doesn't just affect one organ system. In the circulatory system, you get persistent endothelial senescence, which is the death of endothelial cells, contributing to atherosclerosis and diabetic cardiomyopathy, so essentially cardiovascular disease. Hypoxia-induced memory in cardiac fibroblasts leads to sustained fibrosis, again related to heart disease. In the nervous system, hyperglycemia alters DNA methylation in something called Schwann cells in neurons, and this leads to myelin structure disorders and chronic neuropathic pain. And it's also linked to cognitive impairment and neurodegenerative diseases like Alzheimer's, driven by brain insulin resistance. And the kidneys are affected. Persistent differential methylation, i.e. methylation pathways that are all skeweth. This promotes that ROS, oxidative stress, and cell death in kidney tissue, leading to diabetic kidney disease. And also, probably won't surprise you, but cancer. Metabolic abnormalities can create an epigenetic imprint on cancer cells that drives that proliferation and drug resistance. Residual cancer cells may retain these glycolytic traits through DNA demethylation even after oncogenic signals are removed, and this does favor recurrence. And there is, of course, an intergenerational component. Maternal or paternal poor diets can induce what's being called inherited metabolic memory, altering sperm quality and increasing the risk of metabolic syndrome in offspring for up to 2 generations. So it's pretty interesting looking at the term metabolic memory from a poor metabolic health outcome viewpoint. But for what it's worth, I first was alerted to the term after listening to several podcasts actually, with Dom D'Agostino. And this is a flip side, and where it gets interesting from a training and nutrition perspective. So Dom D'Agostino, he has talked about metabolic memory through a completely different lens. And this is a lens of positive physiological adaptation, not negative. And he draws a direct comparison to muscle memory. And I think it does make for a pretty compelling case. So his argument is that metabolic memory is also the body's ability to snap back to a previously achieved state of high performance or metabolic efficiency. In his example, it might take 10 years to build up to a 400-pound bench press, but if you take months off of training, you can return to that level in 2 or 3 months. And that isn't just muscle memory. He argues that that's metabolic memory. And he applies this specifically to ketosis and fat adaptation. the more time you've spent in ketosis, the easier it becomes for your body to shift back into that state after a period away from it, and the more benefits you derive from it. Your body becomes more metabolically flexible, essentially. And it was interesting, I was reading a blog post from Marco Altini, and he's been on the podcast a couple of times, the latter time being about his N=1 experience of cycling his carbohydrate to become more fat adapted. And in his blog post, he talks about his more recent experiences of trialing going back to his usual high carb diet and discovering that it took, I think, about 3 weeks for his metabolic flexibility to be completely suppressed and his fat burning to be well lower than what it was when he was in the height of his sort of carb cycling. However, when he got back to his now usual pattern of eating, which was a high-fat, low-carb diet, putting in carbohydrate to support training, it took no time at all to snap back into his ability to be metabolically flexible, which essentially is an illustration of what Dom's talking about here with this metabolic memory. So a primary driver of this positive physiological response, according to Dom, is mitochondrial capacity. So when you stimulate the body through training or dietary interventions, mitochondrial number and function increase. And even after a break, those mitochondria remain and can respond rapidly to new stimulation. And he actually does make the point that muscle memory is in fact metabolic memory. When a marathon runner's VO2 max reestablishes quickly after time off, those changes are happening in the muscle, yes, but they're fundamentally metabolic in nature. And the mechanisms underpinning this is potentially, again, the gene programs and epigenetic regulation, which is consistent with everything, with the other information about the pathological side of metabolic memory. So the same epigenetic machinery that locks in damage from hyperglycemia, for example, can also lock in adaptations from training and dietary interventions. So I guess the epigenetics, they're neutral, but they're just recording whatever metabolic environment you expose yourself to. And a few other words on this metabolic memory from a sort of a positive physiological standpoint, the Volta Longo and the fasting mimicking diet. Volta Longo's research shows that 5 days of fasting mimicking diet can impact cardiometabolic biomarkers for up to 3 months, which is indicative of metabolic memory in the positive sense. Relatively short dietary interventions can have lasting metabolic effects well beyond the intervention period. And we know this from people who are in ketosis as a way of living, if you like, that the longer you're in ketosis, the more potential there is to change mitochondrial function and mitochondrial biogenesis by altering the way that genes are expressed and also increasing fatty acid oxidation enzymes. And you can also upregulate transporters that get ketones across the blood-brain barrier and cell membranes, which stimulates the production of catalytic enzymes. So it's not just mitochondrial number, but the entire transport and utilization machinery that adapts and persists over time. And interestingly, I mentioned the Volta Longo's work, 3 monthly cycles of the fasting mimicking diet lowered biological age by 2.5 years using the markers that they used in that study, with reduced insulin resistance, lower liver fat, and improved immune markers. So again, these are lasting metabolic effects from these periodic interventions. And these are potentially evidence that short periodic metabolic challenges leave this lasting positive imprint. So what are some practical take-homes for all of this? Number one is that early intervention matters. So if you're dealing with metabolic dysfunction, elevated blood sugar, insulin resistance, dyslipidemia, don't wait. The longer those conditions persist, the deeper the epigenetic imprint and the harder it is to fully reverse the damage even once you get control. And there may also be a real case, this is number 2, for being proactive with biomarker screening. DNA methylation patterns in circulating microRNAs, they're emerging as early biomarkers that can flag risk before clinical symptoms appear. And these may be tests which aren't readily available at your GP or your physician, but there are places like NutriSearch, NutriPath, Genova Diagnostics, and other companies that offer these more comprehensive testings. And it's absolutely worth investigating if there is a family history, for example, of poor metabolic health. Number 3, obviously, your training and diet history is an investment. So every period of metabolic challenge you put yourself through, such as building aerobic capacity, spending time in ketosis, strength training, this creates a foundation that your body can return to more easily. So that mitochondrial capacity and those epigenetic adaptations, they persist. So this is why, a lot of people feel quite disheartened if for whatever reason, these patterns that they used to be able to get into, they're unable to sort of get back to where they once were. So take heart that once you do, it's actually way easier and your body remembers. And number 4 is that lifestyle interventions do have epigenetic power. And I think we do know this. Exercise has been shown to reduce promoter methylation of genes like PGC1 alpha, improving mitochondrial function, mitochondrial biogenesis, and insulin sensitivity. And we know that there are compounds like curcumin, potentially resveratrol, which can modulate these epigenetic marks associated with hyperglycemia. And we also know of the likes of other mitochondrial supplements, which may not be trivial lifestyle add-ons, but they're working at that level of gene expression. And for what it's worth, as a developing field, researchers are exploring what they're calling epi-drugs. And these are drugs like HDAC inhibitors and DNMT inhibitors. And these work in concert to silence genes. So DNA methylation recruits the HDACs to chromatin. I think I mentioned that earlier. And together they create a self-reinforcing silencing loop. So the therapeutic logic for metabolic memory is that you'd need to hit both layers properly to unsilence genes that got locked down during a period of metabolic dysfunction. However, right now, these drugs, which again, this is emerging research as far as I understand it, and I'm no expert here, I'm just reporting what I've read in the papers, they do currently lack the precision in targeting specific sites, and they're not selective for particular enzyme variants. So the idea that you can use something like this to help unblock genes and remove that metabolic memory is still very much more an idea rather than, or a possibility, rather than something that's concrete in nature. So metabolic memory, a super interesting term and double-edged sword. On the one side, periods of metabolic dysfunction can leave this lasting imprint that can drive disease for years, even decades after the original problem is resolved. On the flip side, it's encouraging, right? The positive adaptations you build through training and targeted nutrition also leave a lasting imprint that your body can draw on. And the unifying principle here is that your metabolic environment matters, and it matters most when you're in it. The epigenetics are recording. So the earlier you take action, whether that's getting blood sugars under control or investing in your aerobic base or building muscle, the better the memory is that you're building. All right. Well, I hope you found this interesting. I just thought it was something worth exploring. It got me. I was curious, and I wondered whether you would be too. Let me know. You'll find me over on Instagram, X, and Threads at Mikki Williden, Facebook at Mikki Williden Nutrition, or head to my website, mikkiwilliden.com. Scroll right down to the bottom, pop your name in the box there, and you jump on my email list. All right, guys, you have the best week. See you later.